Welcome to 5.7 Circumference and Arc Length. In this lesson, we're going to be talking about circumference, the definition of a radian, some example problems, and also arc length. So remember, by definition, an arc is a part of the circumference, and we learned about two types of arcs, a major arc and a minor arc, where the minor arc was less than 180 degrees, or half the circumference, and the major arc was more than 180 degrees, or half the circumference. And then when we talked about those types of arcs, we also talked about how to measure those arcs. So in this lesson, we're actually going to learn about another way to measure the arc. So looking at the first one, it says central angle. This is when we measure the arc using the central angle. In this case, arc AB, it's a minor arc. And remember, minor arcs actually have the same measure as the central angle. So in this case, arc AB is 120 degrees because it's the same as the central angle. Okay, so this first method of measuring arcs, this is what we already learned. So now we're going to get into the second one, arc length. This is when we don't want the measure of the arc to be in degrees. We want it to be some unit of length, such as inches, meters, centimeters. Okay, so looking at just this circle, we can see that this central angle is a right angle, so we know it's 90 degrees. Okay, and what else do we notice? Well, if we were to measure this arc in degrees, then we would say arc AB is 90 degrees, okay? Now remember, think back to the definition of an arc. It is just a part of the circumference, so it's actually a fraction of the circumference. Looking at this circle, looking at the entire circle, you can see that the arc AB makes up just 1/4 of the entire circumference, right? Because here's one portion, and if I were to color in, this is a second portion, a third portion, and the fourth portion, right? Just imagine as pizza slices. You have 4 pizza slices, and this arc, this yellow arc, would be 1 pizza slice out of 4 pizza slices. So this arc AB actually just makes up 1/4 of the entire circumference, okay? So to solve for arc length, you would, arc length equals, it is just some fraction, the fraction of the arc length. So 1/4, because the arc length makes up 1/4 of the entire circumference, 1/4 times the actual circumference. So I'm going to tell you that the circumference here is 20 centimeters. Later, we're going to talk about how to calculate the circumference using a formula. But for now, just accept that it's 20 centimeters. I made it up. So the arc length in this case would be 1/4 times 20 centimeters, which is 5 centimeters. So arc AB is 5 centimeters. Okay, so in this circle, you can easily determine the fraction of the circumference. But what about if you were given this type of arc? At least for me, I can't easily tell the fraction or how much the arc makes up of the circumference, right? So again, this arc would be 120 degrees because it's the same as the central angle. But remember, how many degrees are in a circle? There are 360 degrees. So 120 degrees out of 360 for the entire circle would just give us 1/3. So now we determine that arc AB makes up 1/3 of the circumference. Okay, so you can take the measure of the arc in degrees, divide it by the total degrees in a circle, which will always be 360, and you should get the fraction of the circumference that the arc makes up. Okay, so what is the arc length in this case? Oh, right, and the circumference here is 30 centimeters. Again, I made it up, but just accept it. Oh, no. Okay, sorry. So, arc length for this circle would be the fraction, 1/3, times the circumference, which is 30 centimeters. So, our arc length here is 10 centimeters, right? Because 1/3 times 30 is the same thing as 30 over 1, and you just multiply across. And you simplify. So our arc AB is 10 centimeters. Okay, so that's 2 ways to measure an arc, whether you measure in degrees or in units of length. So now let's get into the circumference. So the circumference, remember, it's the distance around the circle. So you can kind of think of it like the perimeter when you learned about polygons. Perimeters of polygons, where you just add all sides, except for this case the circle doesn't have sides, they're just curved. So how would you measure the distance around it? Well, there's actually a formula. This is the formula right here. C equals 2 pi r. So, which is just 2 times pi times r, okay? And what is pi? Pi is just a real number, but it's an irrational number, meaning you can't write a fraction to give pi. And pi is a really long number. It's like 3.14 and it just goes on and on, so there's a lot of digits. So it's an irrational number because you can't write a fraction to give you that crazy long number. Okay, so we usually just write it as this symbol, pi, and then r stands for the radius. Okay, so let's try to calculate the circumference of circle A. Well, we know that circumference equals 2 pi r. 2 pi, we can leave it as is, and we can leave it as is, and in this case the radius is 6 centimeters. So our circumference would be 12 pi centimeters. Now if you wanted, you can take 12 and multiply it by pi on a calculator, because pi is just a really long number, right? It's just 3.14 and goes on and on. So you can leave it as 12 pi, or you can multiply 12 times pi to give you your circumference, but this is fine too. Okay, so look closely at the formula for the circumference, 2 pi r. Can you come up with another formula for circumference using what you know? You can pause the video. Okay, if you pause the video, hopefully you recognize that you see a 2 and an r. And you know that the diameter is actually 2 times the radius, right? Because if I drew it in here, this would be the diameter. Let's call it CB. And the diameter is just 2 times the radius. So if we wanted to write another form of the circumference, you could write pi d. So pi times the diameter. So yeah, those are two different ways to look at it. It depends if you'll be given the radius first, the diameter first. But yeah, you can use both of those and you should get the circumference. Okay, so now let's talk about a radian. What is a radian? So this is, by definition, the measure of the central angle when you lay the radius on the circumference of the circle. Now this is a bit confusing to me when I first read about this, so let's try to go through this. Okay, so remember when we measured angles, we would, let's say we have center A, and this is a radius. Let's say segment AB is our radius, and we had another radius. Let's call it AC. Actually, let me draw it like this. Okay, AC. So two segments, or two radii, they're meeting and they share an endpoint, and because of that they form an angle. Oops, I should be doing a square. They form an angle, and this angle is 90 degrees. Okay, where they share vertex A, vertex is A. They share an endpoint A. And the angle they form is 90 degrees. So when you measure angles, you can actually measure it in degrees or in radians. Okay, you'll see this in other math classes where you'll use radians instead of degrees. That's why we use both, because sometimes one is more useful than the other. For example, when you're doing trigonometry, radians would be more useful than degrees. So, okay, so let's try to break down the sentence, this really long sentence. So if we were to, let me erase this. So here is our radius, AB, and let me say that it's 5 centimeters, okay? And remember, we can measure arcs in either degrees or in units of length. So if we wanted to take this radius of 5 centimeters and we want to lay the radius on the circumference of the circle, that means we want to take AB and we want to put it on top of the circle, on the circumference of it. So we would get, let me zoom in so I can draw this neatly. I'm going to draw this. So we would take the radius and we can lay it on top of the circle, right? Remember we were talking about how we can measure arcs? This looks like an arc, right? Let's call it CB. This should remind you of an arc. So we can say this arc CB, we can measure in degrees or by its length. And since we're laying the radius, which is 5 centimeters on top, then this arc should have a length of 5 centimeters. And then we'll just connect the points, and this will form an angle, right? Because we have segment AC meeting with segment AB, and because they are connected, they form an angle. That angle is actually 1 radian. 1 radian. Don't get radian confused with radius, but it's not a coincidence that they are very similar because you're taking the radius length and you're laying it on the circle. I should zoom out, sorry, so you can see the definition. Okay, so let's erase, maybe I'll keep this here. I'll draw another circle. Oops, I'll draw another circle. And let's draw the same thing we had earlier. A, B, and C. So remember, this angle is 90 degrees. So you can measure this angle in degrees or in radians. So you don't have to know this, but you can convert degrees to radians and you can convert radians to degrees as well. So I'm going to tell you that 90 degrees is also the same thing as, pi over 2 radians. I know that looks weird, but just bear with me. Now, you see that this part of the circle is 9 degrees, and we also have this part of the circle, and then we have this part of the circle, and then we have this part, right? So we have 4 equal parts. So really, we have pi over 2, and then this part also makes up pi over 2 radians, and then this part, sorry, that's so messy, also makes pi over 2 radians, and then this part also makes pi over 2, right? And then we can just add them all together, plus pi over 2, plus pi over 2, plus pi over 2, and remember pi is just some number, so if you want, you can think of it as 1 pi over 2, so this looks like a bunch of halves adding together, right? Half plus half plus half. Maybe that's not a good way to look at it. Okay, so how many pi's do we have? We have 4 pi's. That's ugly. 4 pi's, and you're dividing it by 2, and you simplify, and you get 2 pi. My point is, there are 2 pi radians in a full circle. Remember how we kept talking about there are 360 degrees in a full circle, and we can measure angles in degrees or radians. So if there's 360 degrees in a full circle, then there are 2 pi radians in a full circle, and that will always be the case.